My name is Richard Foster, and I'm from North Carolina Central University, and this is my project on exploring drive times to healthy food options in Durham County. In some neighborhoods in Durham County, convenience stores and fast food restaurants are widely dispersed, while supermarkets are few and far between. This study seeks to analyze drive times to healthy and unhealthy food options in Durham County and see if there's any statistical evidence of clustering of these food sources. With data from InfoUSA, the U.S. Census Bureau, and the North Carolina Department of Transportation, spatial analyst tools can be used to create drive time intervals to these food options. These results can then be overlaid on a map of median household income to explore any correlation between income and food availability. Access to healthy food options is often a problem in low-income communities. A 2012 study states that health-related issues such as hypertension, obesity, and diabetes are prevalent in low-income communities. The study further suggests that vehicle ownership is the most important determinant as to whether a family can access healthy food options. Furthermore, a 2011 study identified 6 major barriers to accessing healthy food options for lower-income communities, and their top 2 barriers were cost and transportation. Thus, there is a great importance for analyzing travel times to these healthy food options. It is important to clearly define what healthy and unhealthy food options are. The 2012 study defines healthy foods as whole grains, fruits, vegetables, and lean meats. The study further defines unhealthy foods as fast foods due to fat, sugar, and sodium content that results from processing and preparation methods. Sources for healthy foods include grocery stores and farmers markets, where fresh fruits and vegetables can be purchased. Sources for unhealthy foods include fast food restaurants and convenience stores, where more processed food options can be purchased. And the hypothesis for this study is that people in lower income communities will not only have less access to healthy food options, but they'll have more access to unhealthy food options. Using business data obtained from InfoUSA, I first had to query out the selected businesses. For this study, I went with the big names in grocery stores and fast food restaurants because many of the convenience stores are actually labeled as grocery stores, even though they don't sell any fresh produce. Convenience stores were already queried out, so no additional work was needed to select them. Additionally, a 10-mile buffer was added to the perimeter of Durham County to take into account areas near the border. And we'll see why that's important when we get to the maps. Road characteristic data were obtained from the North Carolina Department of Transportation. This data stores the length of a road as well as the speed limit for the road. And with these 2 variables, one is able to calculate drive times for the roads, which can then be used to create a transportation network. With this transportation network built, tools can be run to create drive time intervals around given points, which in this case will be the healthy and unhealthy food options. And with this analysis complete, we can then superimpose this network over U.S. Census data to explore the median household incomes surrounding these point sources. And for this study, the block groups being analyzed are those with a median household income of $30,000 or less. So this is the map for drive times to grocery stores, and the red areas indicate drive times, and as they get darker, the drive times get longer. The black outlines here are the block groups where the median household income is $30,000 or less. You can also see why incorporating the buffer helps to take in for areas near the border. For example, these 2 grocery stores are influencing drive times to this area over here. And then similarly, these guys influence this area here. As we can see, most of the low-income block groups have pretty low drive times to grocery stores, but there's still some areas that are in the darker shades, especially down in here and over here and up here. But this area is downtown. And for convenience stores, we can see that nearly all of the low-income block groups have extremely low drive times. There are only a few areas with any of the darker shades of red, and again down here and over here and up here. But most of this area, I mean, you can clearly see a difference between these. And for fast food restaurants, we see a similar pattern as the convenience stores with a lot of low colors in here. And just on a side note, I like this map because you can see some of the major roads, like for example, that 70 that goes across there, and 15501 up in here. None of that is related to the study at all. I just think it's kind of interesting. This chart shows average drive times to healthy and unhealthy food sources and the number of block groups affected by these drive times. The results of this point polygon analysis illustrate that individuals living in lower income communities within Durham County have shorter drive times to unhealthy food options. On average, the block groups in the study area contain 1,500 residents each, meaning approximately 9,000 people can access unhealthy food choices more quickly and easily than healthier food options. Now we will try to analyze any statistical evidence of clustering within the study area. Using a Quadrat analysis, one is able to lay a grid onto the study area to analyze the amount of features within each quadrant to see if there's any discernible patterns. First, the quadrant size must be calculated, and this is done by using this formula where L is equal to the length of one quadrant, N is equal to the total number of features in the study area, and A is equal to the area of the study area, which in this case is Durham County. Additionally, we have to make sure to measure the study area in square feet to make sure that it matches up with the state plane projection being used. Once the quadrant size is calculated, the next step is creating a fishnet to overlay onto the map. Since the length is dependent on the number of features, each of the food options will have a different sized fishnet. This is an example of the grocery store fishnet I made for this study. Once each of the three fishnets are created, we then run a spatial join to attach the features to the corresponding fishnet. A summary can be run, which will produce a count for the frequency of features in the quadrant, and with these data, we can calculate a Poisson distribution and compare. So a Poisson distribution is useful to tell if a set of points is random or not. This is the formula where lambda is equal to the number of features divided by the number of quadrants, and x is equal to the count, which in this case is the number of quadrants associated with the frequency of the features. We can then compare our Poisson results with our results from the quadrant analysis. In this case, the Poisson results will be what we would expect to see if the points were randomly thrown on the map, and our results from the quadrant analysis will be what we actually observed. And as we can see from the line graph, our Poisson result for the grocery store deviates from our observations, but the curve is fairly close. And for fast foods, we get a couple spikes in our observed quadrants where the Poisson suggests we should have 0. And similarly, our convenience store results show roughly the same spikes where the Poisson suggests there should be 0. In conclusion, there doesn't seem to be enough evidence to suggest that Durham County has a food desert problem. However, all of this data proves that Durham is in fact a food swamp, where residents have more access to unhealthy food options than healthy food options. Additionally, more work can be done to further solidify these observations, such as downloading sidewalk data to analyze walk times to these food sources, and doing some field research to check the validity of some of the smaller names in grocery stores. And this would help boost the number of features being used in the study, which would help with some of the statistics. And finally, running a Kolmogorov-Smirnov test to the Poisson results to help clarify if there is any clustering patterns. Thanks.